thanks, Ivor, again for this amazing speech. And one point I want to bring out is that one of the biggest tragedies in life is not knowing if you are diseased, or even if you are diseased, not knowing what to do about it. So the purpose of my speech would be to kind of bring some real-time interventions or lifestyle practices that you can implement into your life and kind of gain this insight of how can I see my body going, in what directions am I heading towards with my health, and what are the trends. So yeah, so the topic of my speech is going to be balancing the anabolic and catabolic cycles of life. So this is going to be this sort of a like a metaphorical title to it as well. So let's start from what is life itself. This is life basically. It's a collection of genetics, DNA sequences, chromosomes, mitochondria, everything, bacteria that is ultimately going to create you as a superorganism. And when you dissect the life into two parts, then at first you're going to get where life sprouts into existence is going to be DNA replication, cellular growth, and that's going to be the term for that is going to be called the anabolism, where you're growing. And the opposite to that is entropy, or life itself, the process of living and dying, and that's going to be catabolism. Those two are these balancing counterparts of life. And when you look at it from a metabolic perspective, then these two are always interacting and they're balancing each other, but depending on the input and output of your system. So at the top we have fuel, which would be everything that is going to allow you to live, like oxygen, energy, food, calories, everything they included, and that's going to go into your metabolic furnace, so to say, and in that is going to be cycled into, it's going to be broken down into energy through the process of catabolism, and through the process of anabolism, you're going to build that energy into whether muscle tissue, bones, fat tissue, and brain cells, and everything. So a good picture to think about it is that when you're born, you're being anabolic, you're being born into this world, and when you die, you're going to eventually lead to the point of ultimate catabolism, where you're being recycled back. And the same principle can be found in the example of like building tissue, like muscle tissue and everything, that's anabolic. And creating energy itself is catabolic as well. You're literally breaking down energy molecules so that you can recycle them back into like literally building this tissue and starting to live. So you can see this trend in your everyday life as well as a human being. Like when you're born, then you're being very anabolic, so to say. You're producing a lot of growth hormone, and that's going to help you to kind of build this new tissue and build new bone structures and everything included. And as you age, all of these anabolic hormones, they begin to drop just because of the process of entropy. Like growth hormone decreases as you age. And usually after 20 and after 30, that's when your growth hormone is really going to begin to plummet, and you're beginning to enter the catabolic cycles of life. And the same trends can be found in like overall muscle mass and overall strength as well. Like early life, you're growing, developing. During your adulthood, you're kind of maintaining it. And in your older life, the general trend is that you begin to lose a lot of your muscle mass and everything included. You're waning down yourself. And one of the biggest reasons why we age are connected to these anabolic and catabolic cycles. So a huge cause of aging itself is this term called sarcopenia, which translates into muscle loss. And as you saw in the previous slide, growth hormone declines, and that's going to basically lead to sarcopenia. That's one of the causes of why you kind of go into this catabolic mode, because you're not producing that much growth hormone, you're not producing that much testosterone, and you don't have enough of the anabolic hormones to sustain your lean muscle. But sustaining your lean muscle is incredibly vital for your general longevity and lifespan, not because of just only having the youthfulness, but at the same time, it acts like a huge metabolic organ as well, muscle tissue. Like it protects against, it makes you more insulin sensitive, which will then protect against heart disease. It's going to help you to have some cognitive performance as well. and of course maintains joint integrity and everything. And a lot of people, why people die is, or why old people die is like they fall off stairs, they broke their hip, and they're gonna simply, they don't have the resilience and robustness. So when you look at the extremes of these cycles, then on one hand we have like extreme anabolism, which would be like these huge bodybuilders who are taking it to the extreme, and on the other hand we have like an old person who is simply losing all of the muscle mass because of being too catabolic. But the problem is that both of them can lead to like death, in a sense that both of them can accelerate your aging, and you don't want to be at the ends of each spectrum, at the bottom ends. So you want to achieve this balance of where how can I balance these cycles, and to in so doing increase my lifespan, and also promote longevity and live a more healthier life. So let's move on into some more technical tips, in a sense. So this is not the food pyramid. This is not the Illuminati pyramid either. It's the protein kinase pyramid or triad that is going to it's going to give you this illustration of how your body detects and balances these cycles of anabolism and catabolism. So this is going to describe the main nutrient signaling factors that are constantly monitoring the energetic status inside your system. So your body is constantly, from the perspective of evolution, is constantly detecting how many nutrients are circulating your bloodstream, and in so doing, it's going to detect, okay, I have these nutrients, okay, I can be anabolic, or if I don't have enough of these nutrients, then I'm going to have to shift into a catabolic state because of not having the essential nutrients for that. So on the bottom left corner, we have mTOR, which is the main anabolic pathway of your body. It's short for mammalian target of rapamycin. So it's this sort of a genetic fuel sensor that directs cellular growth and anabolism. It's going to make you build muscle. It's going to promote telomere lengthening. It's going to drive DNA replication and everything that is related to anabolism and growing. And on the top, we have AMPK, which is another critical fuel sensors from an evolutionary perspective as well. And AMPK translates into AMP-activated protein kinase. So AMPK detects also the lack of nutrients, and it mainly gets elevated in the presence of energy starvation, when your body gets depleted of nutrients. When you run out of its immediately accessible calories and things like that, then your body is like a very adaptable machine, and it's not going to die immediately. It's going to simply start to mobilize a lot of the stores or the energy stores it has stored inside its body, like in the bone matrix, in the adipose tissue, and everything included. So AMPK is helping you to kind of survive periods of energy deprivation when you were starving in the past as a hunter-gatherer, or when you were simply facing famine. So AMPK then is going to lead to the activation of this fuel sensor called ULK1, which will then activate this pathway called autophagy. Autophagy is what we'll talk about next, but autophagy is like the main catabolic pathway that will help to mobilize a lot of the body's resources to survive. So what is autophagy? Autophagy, it translates from Greek autophagos, if I'm not mistaken, and it means self-digestion or eating of self. And it literally is the process where your healthy cells, they start to move around inside your body, and they're starting to eat the old and weak cells so that they can be converted back into energy. So it is literally like some sort of Hunger Games happening inside your body, and it's going to help you to sustain yourself, and it promotes the survival of the healthy cells, because you want to get rid of the old and weak cells while maintaining the healthy cells, so you can maintain your longevity. In a sense, you don't want to lose the good stuff. And there are many benefits, scientifically proven benefits of autophagy as well, such as it's going to reduce inflammation, it's going to strengthen your immune system against pathogens, anti-aging benefits, longevity benefits. It can cure a lot of diseases, and even there are some studies that it can even cure cancer and tumors and everything like that. So it's the cycling of old and weak cells, and it's going to eliminate a lot of these pathogens and viruses as well. So it's like this your body's innate healing mechanism that is it's even recorded in a lot of ancient scriptures and these different texts as well. So another one of the reasons why you age and what's the cause of death is there's this theory called the mitochondrial theory of aging, which basically is that as you age, your mitochondria, which are the powerhouses of your cells, that the cells, the organelles that are responsible for producing energy, those cells, they're gonna eventually waste away, and that's going to lead to many other issues related to energy production. You don't have enough energy, you have a weakened immune system, and because of that, you're more susceptible to disease and everything included. So you want to maintain like healthy mitochondria as long as you can and make them more powerful in a sense. So everything that you are exposed to on a daily basis, like breathing, these lights, moving around, eating, sleeping, those things, they're causing some sort of oxidative stress, or they're causing some damage to the mitochondria. It's inevitable. Like entropy itself is the accumulation of damage or oxidative stress to the mitochondria. And that leads to the creation of these different free radicals and reactive oxygen species that will, if not controlled, then they will eventually still lead to apoptosis, which is cellular death and the destruction of your mitochondria. But on the other hand, you can protect against that. It's possible through the process called mitophagy. Mitophagy is like mitochondrial autophagy, where your healthy mitochondria will be recycling old and weak mitochondria back into healthy mitochondria. So that's going to protect against the mitochondrial dysfunction. So it's like the autophagy is like one of the critical aspects of longevity and maintaining all these mitochondrial functioning. And you can think of it like Pac-Man indeed, where the Pac-Man is hunting down these ghosts, which are like unhealthy cells. And let's move on with the AMPK. As we saw in the previous slides, AMPK is the one that is going to help to activate autophagy, to activate this process of recycling. So AMPK is always being activated by these things that put more energetic stress onto your body. And one of those things that AMPK helps to activate us further are things like fatty acid oxidation. You're going to burn more fat. You're going to improve glucose transport. You're more insulin sensitive. You're going to trigger autophagy. And but the problem is that AMPK is still like a catabolic fuel sensor. It's going to block the other anabolic pathways like protein synthesis and growing. So you have, on one hand, you have mTOR that is going to promote growth, and on the other hand, you have AMPK, which is promoting catabolism, and it's going to block mTOR so that you could have the ability to recycle it, because your body is quite clever in a sense. It's not going to activate autophagy if it doesn't feel the need to. It only does it when it's under like serious energetic demands, when it needs to produce more energy. But autophagy isn't, the end-all be-all, and it's not all good all the time. When you don't have enough autophagy or dysfunctional autophagy, then that will still lead to like weakness and atrophy. You're not being able to sustain your lean muscle mass. And on the other end of the spectrum, on the extreme, if you have too much autophagy, then you will also be like causing detrimental damage to yourself. Like in the example of aging, where you lose a lot of muscle mass, that's like too much autophagy is still bad. So the aim is to have this balance where you can be at an optimal dose of autophagy with these daily interventions. So let's go back to here again. So we saw that AMPK, energy starvation, nutrient depletion will lead to autophagy. And autophagy is blocked by mTOR. mTOR is the growth pathway that will block autophagy. If there's too much mTOR, then autophagy can't be activated, because those two things are constantly being your body wants to prioritize anabolism and it wants to promote as much storage of energy as possible. So what is mTOR? Like I said, mammalian target of rapamycin, the main growth pathway of your body. And mTOR is mostly activated by nutrient factors and growth factors such as insulin, IGF-1, glucose, carbohydrates, and amino acids as well, protein. And one of the main amino acids that drives mTOR, or the most powerful one, is leucine, which is then going to lead to this cascade of different metabolic pathways that's ultimately going to end up with muscle protein synthesis or growth, cellular replication. So again, these things are constantly being balanced out. At the top, we have insulin and IGF-1, which happens in nutrient excess if there's too many nutrients inside your body, whether that be carbohydrates or amino acids, whatever they may be. Those are going to block AMPK and autophagy. And nutrient excess is also be activated by too much mTOR, and that will then accelerate aging and can lead to some higher risk of cancer. And on the other hand, we have caloric restriction, where your body is depleted of energy. It's very efficient with the fuel that it has. It doesn't have excess. It's, being able to work with what it's got as efficient as can, and then will lead to like a longevity and better metabolic health and longevity. So let's go further. IGF-1, which we saw activates mTOR, is one of these. IGF-1 is like a growth factor that gets activated by growth hormone in the brain from the pituitary gland. Whenever your pituitary gland releases growth hormone, then growth hormone will send a signal to the liver, and the liver will then release IGF-1 into the bloodstream as well. IGF-1 is then going to promote muscle growth, bone strength, and tissue repair, and general anabolism. And studies, meta-analyses have found that if you have too low levels of IGF-1, then your risk of dying increases. So on the left, we have low levels of IGF-1, and on the right, we have also high levels of IGF-1. So both are bad again. Too low levels of IGF-1 and too high levels of IGF-1 can be detrimental. So again, in the middle, somewhere in the middle, is like a good optimal dose for longevity. And again, these can be taken as illustrations. So, caloric restriction, energy depletion, it's one of the few ways of scientists actually know how to promote lifespan in practically all species, whether that be yeast, bacteria, monkeys, mice, and other life forms. So this graph shows rhesus monkeys, where you can see when they're fully fed, then their age is somewhere, 30 months or so. 10% caloric restriction leads to like a few months of extended lifespan, and 50% caloric restriction almost doubles their lifespan, or at least 50% increase in their lifespan. And there have been even some studies on yeast cells where caloric restriction doubles the lifespan of yeast by 100%. So it's one of the few ways of actually we can see that it works. And probably the same principles apply to humans. It's not conclusive, but there are some similarities. And one of the reasons why caloric restriction promotes your lifespan, there are many things that can contribute to it, like lower insulin and lower obesity and better metabolic health. But a lot of evidence is showing that the effects of caloric restriction are actually directly linked to autophagy, like we mentioned earlier. So they've actually done some studies on some mice where they genetically modified the mice in a way that they wouldn't be able to activate autophagy because of some genetic mutation. And those mice, even though they were caloric restricted, they didn't live longer. But the ones in another group where they were proficient at causing autophagy, those mice, they still lived longer. So the key is autophagy and maintaining this recycling of old cells so that you can clean out the damaged particles inside your system that are simply causing oxidative stress. So the key is to activate autophagy, not caloric restriction, because you can eat very few little calories and basically starve yourself without living longer just because you're not activating autophagy, if you get what I mean. So you have to, and at the same time, you can activate autophagy without having to starve yourself. So you have to be, you can biohack it in a sense. You have to be smart about it, and you don't have to starve yourself to promote your lifespan. You can do it with these different ways of how I'm going to share with you. So how to increase autophagy? One of the best ways is intermittent fasting. And when I say intermittent fasting, then I'm not necessarily meaning like starvation. There's this immediate idea that you might come is like starving yourself and such. But intermittent fasting is simply time restricting the period where you consume your calories. And one of the best examples of it, one of the most convenient examples of it is like during the 24-hour period, you fast for 16 hours and you eat all of your calories within 8 hours. So you can consume the same amount of calories as you would on a normal diet, but you simply do it in a very smaller time frame, and you maybe skip a breakfast or something like that. And because of that, you're gonna allow autophagy to be activated, because autophagy gets activated only in like energy depletion. But if you're eating small calories, whether that be like a small breakfast or something like that, then you're not gonna allow autophagy to kick in. But if you simply extend the fast and you maintain a 0 caloric intake and you fast for maybe like 16 hours, then you're going to allow autophagy to actually, do its work. And that's going to promote longevity without necessarily restricting your calories entirely. And other things to look out for is to control their insulin and blood sugar again, because those are going to be driving the mTOR activation. Caloric restriction, again, to some extent will be beneficial, but there's this dichotomy again, or this trade-off of if you restrict your calories too much, then again you're going to be predisposing yourself to metabolic disease. So I would simply focus on the intermittent fasting part and simply time restricting your food. Then of course exercise and training are again some ways of promoting autophagy, mainly aerobic exercise, in this case like cardio. That's going to be more pro-autophagy than resistance exercise. And other foods like hormetic foods and herbs, spices, certain foods that I'll share later, those are also going to be having some autophagy effect. And what I also think is a really good health intervention and disease prevention is like these extended fasts, where you fast for like 3 to 5 days a few times a year, which are going to be good for going really deep into the autophagy pathway and really recycling all those potential pathogens and diseases that you may come across. So like really good prevention. What about mTOR? Like I said, you want to activate mTOR as well to sustain your health span and longevity. So resistance training is the best way to activate mTOR, lifting weights and focusing on strength movements to actually strengthen the bones as well. Driving muscle protein synthesis is also crucial. Like a lot of people say that, you shouldn't eat protein or whatever, but if you don't eat protein, if you don't get enough of the amino acids, then you're going to actually promote sarcopenia and lose muscle mass. So you actually have to eat. You have to balance it with the catabolism. And the best sources for that is like amino acids. The most powerful for that is leucine, which I'll share with the foods in the next slides. And other things like supplements like creatine monohydrate, which is supplement found naturally it's found in red meat. But as a supplement, it's also like very convenient. It's going to help you promote more ATP, and it's going to help to maintain like muscle mass. And phosphatic acid is also like this lipid that is produced during exercise. Some foods contain it as well. In the next slide, I'll share it. And generally being in a caloric surplus or eating more food is going to drive mTOR. So when you look at these, let's say in a real life example, then these are the daily meal cycles which you would eat during the day. So the red one would be like activation of nutrient signaling. You consume some calories, and that's going to either increase insulin or increase mTOR. And this is like a traditional 3 meals a day. So the green zones would be these periods of fat burning and periods of autophagy. So this is like a three square meals a day, which doesn't really give you the good balance, because like 12 hours of eating, you don't really go into autophagy with that time period. But in the example of the 16 hours of fasting and 8 hours of eating, you simply skip one meal and you're going to prolong the period where your body can go into this state of autophagy a lot faster. And that's going to be like a really good, really simple, convenient thing everyone can do in a sense of simply time restricting their daily food intake. And if you want to really promote it further with autophagy, then you can also take it even further and consume your food only like once in one sitting during like 4 hours or whatever it is. So there are different ways of you can do it. And a real overview of how to actually balance it. Daily time restricted feeding. You consume these autophagy boosting foods during the first part of the day. Then you stimulate AMPK with exercise. You train low glycogen in a sense of you deplete your body with exercise. And after the workout, when you're wanting to repair, you want to promote muscle protein synthesis, then you consume these things that help you to sustain muscle mass. Because if you are fasting, then you want to balance it with adequate protein and things like that. So what are these foods that can contribute to this? Autophagy boosting foods are these adaptogenic herbs like ashwagandha, ginseng, curcumin, ginger, these Ayurvedic herbs, and also like medicinal mushrooms like chaga, reishi, lion's mane. Polar Nutrition in the back they have like a few examples of that. Also sulforaphane vegetables like broccoli and cauliflower, coffee and tea as well. They're gonna activate autophagy to a little bit. Polyphenols and resveratrol from berries, and these anti-diabetic drugs as well, like rapamycin, metformin, and berberine. They're gonna suppress insulin and blood sugar and mTOR as well. So what about mTOR? Again, leucine-rich foods like eggs, dairy, those are the highest sources of leucine. And generally, mTOR can be activated by protein as well, like poultry, meat, fish, and also like starchy carbohydrates, like rice, potatoes, those things. And one interesting thing is that if you combine carbohydrates with protein, then you're going to drive more insulin. You're going to increase insulin a lot more than if you were to eat maybe like simply protein or such. So it can be, think about it. Do I need to spike my insulin that high with combining carbs and protein, or can I achieve the same result by eating simply low carb and protein? So you have to kind of know what your goals are. And again, like I say, that it's about balancing the cycles, but in reality, there is no real balance. Like you're always tipping from one end to the other, whether that's during the fasted state, you're being extremely catabolic, and when you're eating, you're being more anabolic. So the balance is almost like a myth. It's a constant process of cycling between those processes. So that's the end of my speech, and these are the places where you can find more of my content about these different interventions. And I want to thank you for listening.
Awesome. Thank you.
Yeah.
So out of the list of foods that activate the mTOR pathway, I think I did most of them this morning. Expect medical, pharmaceuticals like metformin, these anti-diabetic drugs. So what do you think about using such kind of interventions?
It's in a sense of it's much easier to avoid the bad stuff than it is to try to compensate for it. In a sense, you eat some cake, which is going to drive your blood sugar up.
Yes.
And you can potentially take something like metformin or berberine to lower the blood sugar. But in a sense, like the much easier thing to do would be to not eat the cake at all and avoid the blood sugar spike in the first place. So like you have to think about it. Is biohacking, in a sense, am I biohacking some sort of a habit, or am I biohacking the response?
Absolutely.
So like I would say like depends on the situation, but yeah, in most cases, avoiding or removing the bad stuff is a lot more effective for both every aspect of life.
But in the end, like habits, those die hard. I'm going to be talking about that after lunch. We have time for one question. So anyone in the audience wants to dig into Siim's brain for a second? Yeah. Here we have the winner is. Here we go.
Thank you. I have one question. I have had that longer period that I haven't eaten, that I have eaten like 2:00 afternoon first time, and my fasting blood glucose level is 7.9 before the lunch. And what should I do? Because I know that this is way too high level.
Mm-hmm. Yeah, like generally it can be that while you're fasting, your blood sugar may rise. And there are several reasons for it. For instance, one of the reasons might be because of the cortisol aspect of your body. It's in a catabolic state which will drive up a lot of the stress hormones in your body. And cortisol will then help to mobilize some of the blood sugar stores that are inside your body to kind of sustain energy levels and maintain blood sugar homeostasis. So one of the reasons why this happens is because of a slightly like a poor metabolic health. And those things, they can be fixed over the long term by simply starting to restrict your carbohydrate intake a little bit, and then incorporating some more exercise in a sense of making you more insulin sensitive over the long term. Because, you know, these things, they may fluctuate. You know, if you are stressed out, then that can also drive up your blood sugar levels. But in the grand scheme of things, you want to focus on the lifestyle interventions that are going to help you to maintain lower blood sugar levels by default. And those are like eating less carbohydrates and less sugar, and also being more physically active to shuttle that glucose into the right place.